going to continue with our mass-to-mass stoichiometry problems. So looking at number 4 here, how many grams of copper 2 sulfate will react with 5 moles of aluminum? So let's kind of focus in on our given and our unknown. So our given is what we know a number for. That's going to be our 5 moles of aluminum. Now we're starting at moles, so we are actually not starting here at grams of given. We are starting at moles of given. So I'm going to kind of fill that in, that I am starting with 5 moles of aluminum. And where are we going? The problem is asking us to solve for how many grams of copper sulfate. So we're going to grams of the other chemical. We're going over here to grams of unknown, and that's going to be grams of the copper sulfate. So to fill in the middle section, that's going to be moles of the unknown. The unknown is the same chemical as this other unknown. That's going to be the chemical copper sulfate. All right, so I was just about to get started and I realized this is not a balanced equation. So I'm going to take a look at it. I see that aluminum is not balanced. I see that sulfate is not balanced. So I generally start with my metals. So aluminum is 1 versus 2. So I'm going to put a 2 in front of the aluminum metal. The sulfate has 3 on the product side, but only 1 on the reactant side. So I'm going to put a 3 in front of the copper sulfate. And now, of course, copper is not balanced, but I can easily put a 3 on the product side. So I have a balanced equation, and I am going to set up my conversion. I'm going to start with my given, which is 5 moles of aluminum. All right, I know that I have to bring that unit down diagonal, moles of aluminum, and then I'm going to think through what comes next. Well, moles of given, we go to moles of our unknown. So next up is going to be moles of the copper sulfate. Come back for the numbers later. I bring that down diagonal because I know I'm not done, moles of copper sulfate. And next in my molar roadmap, I'm going to grams of the unknown. That's going to be grams of copper sulfate. Okay, so just like before, I'm going to put a purple box around the section that I'm focusing on. Right here I have moles to moles, so I'm going to use the coefficients from the balanced equation. Copper sulfate has a coefficient of 3, so that will go on top. And then aluminum has a coefficient of 2, so it will get the number 2. All right, so my mole to mole conversion is taken care of with coefficients. Next up, I have grams to moles. I know that for grams to moles, I use 1 mole equals the molar mass grams. So I put a 1 in front of moles. And then I need the molar mass of CuSO4. So I'm going to do a little calculation up here at the top where I'm putting a little star for that. So copper has a molar mass of 63.55 plus sulfur, 1 sulfur is 32.06 plus I have 4 oxygens because CuSO4, so that's 4 times 16. So we'll do this quick little calculation. Grab your calculator. We get 159.61. That is our molar mass of copper sulfate. All right, so we are ready to calculate our answer. I'm going to erase some of the extra stuff we have here. So I am going to multiply the numbers across the top. So follow along with my red dot. 5 times 3 times 159.61 and then divide by 2. 5 times 3 times 159.61 divided by 2. My answer in my calculator is 1,197. I'm going to round this off to fewer sig figs because I only started with 3. I'm actually going to call this 1,200. That's only 2 sig figs. I'm not going to go into how to make it 3 sig figs because this is not advanced chemistry. So we're going to round it off to 1,200, and that would be grams of CuSO4. Okay, let's do 2 more. Let's look at number 5. Number 5 says calculate the number of moles of ethane needed to produce 10 grams of water. I'm going to remember this time to balance my equation. Now, the 6 here, if I divide it by 2, gives me a 3, which is an odd number. So I already know I'm going to need a 2 in the front. So if I have 2 C2H6, I have 4 carbons, so I need a 4 right here. I have 2 times 6, I have 12 hydrogens, so I need to put a 6 over here. And then I want to add up my oxygens on the product side. I have 4 times 2, that's 8, plus 6. So I have 14, and so I need a 7 right here. Okay, so we have our balanced equation. Let's kind of use our highlighter to figure out what our plan is going to be. So calculate the number of moles of ethane. So we're going to moles. So that means I'm not even going to go and do that last step. Moles of ethane. And so I'm going to go ahead and label that that's moles of C2H6. Where are we starting? Let's keep reading. It says needed to produce 10 grams of water. So the 10 grams of water is what I'm given. So that's grams of the given. And I'm going to go ahead and label that that is grams of water, H2O. So this last one, moles of given here, the given chemical is the same. So it's still H2O. So that's moles of H2O. All right, so we are ready to go with our setup and conversion. So I'm going to put my starting given, 10 grams of H2O in my starting spot. I'm going to bring down grams of H2O. And what comes next in my molar roadmap? It is moles of H2O. Continue on. Moles of H2O comes down because I'm not done yet. And where's next on our molar roadmap? It is moles of C2H6. That is where we want to stop. We don't want to go any further than that. So you're done. Don't go any further. All right, let's plug in our numbers. I'm not going to draw the purple box this time, but let's look at this one I'm circling in red. I have moles to moles. So I want you to pull the coefficients for C2H6 and H2O. C2H6 has a coefficient of 2. H2O has a coefficient of 6. So right here we had mole to mole. We used the coefficients. This next one over here, I have moles to grams. So I'm going to use 1 mole equals the molar mass grams. So 1 mole. And then the molar mass of H2O is 18.02. That's 2 hydrogens and 1 oxygen added up. All right, so to calculate this, we're going to take 10 times 2 and then divide by 18.02 and then divide by 6. I want you to pick up your calculator. Make sure you're getting this answer. You should be getting 0.185. Okay? So 0.185. If you did not get that, again, make sure that you are dividing by both numbers on the bottom. Divide by both numbers on the bottom. All right, so 0.185, that is going to be moles of C2H6. That is how much ethane we need to burn to produce 10 grams of water. Okay, let's do one more. Number 6, calculate the number of moles of iodine. I'm going to go ahead and start kind of processing this. Calculate the moles of iodine. So we're going to go here. We're not going to go to grams. Required to react completely with 62 grams of aluminum. So we're starting at grams. All right, so we're going to have to go from grams of given to moles of given to moles of unknown. All right, so what was my given? My given was 62 grams of aluminum. I'm going to convert to moles of given. That's going to be moles of aluminum. And then I'm going to convert to moles of my unknown. It says moles of iodine. That's moles of I2. All right, let's balance our equation before we move on. I see that iodine has the 3-2 split. So I put a 3 in front of iodine and a 2 in front of Ali3. That makes 6 iodines on both sides. And then I need 2 aluminums on the reactant side. So there is my balanced chemical equation. All right, let's go. We're going to set up our conversion factor and start with our given. That is 62.0 grams of aluminum. I bring down grams of aluminum and go to moles of aluminum. I'll come back for the numbers later. I bring moles of aluminum down diagonal, and I put moles of iodine at the top. All right, my final conversion over here is mole to mole, so I'm going to grab the coefficients. Iodine has a coefficient of 3, and aluminum has a coefficient of 2. The middle conversion factor here is moles to grams, so I'm going to use 1 mole equals the molar mass grams. So 1 mole of an aluminum has a molar mass of, we're going to check the periodic table, 26.98. All right, we're ready for our final conversion. Just like last time, y'all, we have 2 numbers on the bottom, so you need to make sure that you divide by both of those numbers. So I'm going to say it out loud what I type in. 62.0 times 3 divided by 26.98 divided by 2. Pause if you need to catch up. The answer that we get is 3.45. All right, and that's 3.45 what? Well, that's a bad color for this. Aluminum and aluminum cancels. Moles of aluminum and moles of aluminum cancels. Moles of iodine is our unit that remains. So our answer is 3.45 moles of I2. All right, I sure hope that was helpful. Please come ask us questions if you have them, and we will see you next time. Bye.